Thanks for joining me for another edition of Fact Finders. One of the things that drives IT administrators as well as CFOs crazy is the fact that they can't get all the utilization out of the assets that they purchased, for example, storage systems. So today, we're going to try to find out how we can get more utilization out of storage systems. Can we bump it up any, or are you just stuck with more capacity and less performance? Let's find out. All right, so I found my expert to help us address this problem of adding capacity to storage systems while maintaining performance, and that expert is Chris Wood. Chris, thanks for joining me.
It's my pleasure to be here.
Great. Chris, what do you do here at Oracle?
I'm the Senior Product Specialist for the Axiom product, and what that really means is I spend a tremendous amount of time with our customers really trying to understand their workloads so that I can make sure that what we propose is exactly the right fit for whatever their particular storage problem is.
Okay, and you're not new to this. You've been working with storage for a few years, right?
About 34, as I remember.
Okay, great. Well, it sounds like you're the right guy to help us tackle this problem. So is this really an issue? Do customers really face the problem of running out of performance as they add capacity to their storage systems?
Well, what really happens is the majority of the storage systems that we compete with really have two controllers and two RAID controllers associated with them, which is really the core, the brain of the system. Now, you might have 1,000 disk drives attached to this. Now, you can imagine that that means those two controllers are going to get really, really busy. Probably they can deal with a couple of hundred drives at full performance, but then you get to 400 and 500, and suddenly there just isn't enough firepower left to actually utilize that stuff, and the whole system slows down to an unacceptable level.
So what do customers usually do to address this issue of trying to maintain performance while adding capacity?
Well, the first thing they do is they run around and try to tune the system because they're saying, my God, this thing's running way slower than we thought. Well, if the system's at 100%, it's really hard to get 120% of performance out of it. So you're kind of forced to buy another one. That means a new footprint, another thing to manage, another set of licenses. So it becomes a significant financial hit, both from a management perspective and a CapEx, because you got to go out and buy it.
Mm-hmm. Do customers typically tend to, I know I did this when I was an administrator, take their systems and purpose them for one workload versus another?
That's very common. When you realize that you might have a critical online application that if it runs slow, your web store is the performance is so poor that people have page abandonment and they don't buy. That's not the thing you want. So I'll segment just that application on a single storage system to make sure nobody else interferes with it. You can imagine what would happen if I had a critical time-sensitive online application and suddenly someone starts a disk-to-disk backup, or starts uploading, 1 million web pages to archive them. Well, all those IOs for the unimportant application, if they get in there first, they execute first. And you know what? I can't do the Oracle log write, so I can't do the next transaction, which becomes unacceptable.
So how would you recommend that we address that issue?
Well, the first thing you have to do, I'm going to introduce a new term here called quality of service. We've had it in networking for years. But what I really need to do is to be able to prioritize the I/O of an important application higher than that of an unimportant application or less important application. And that means I have to break the first in, first out single queue that all storage systems have historically used. And this allows me to execute the I/O for an important application, no matter how many are stuck in the system, first, rather than have to wait for everyone to get done. So I can align performance with the business value of the application.
So is that what the Pillar Axiom does? Does it help with that issue?
This is an exclusive feature of the Pillar Axiom. In fact, it's patented. And what it really lets us do is, I'll give you an example. Let's say I have a very important online transaction application, a high importance, mail server, and then we're going to want to run archive or disk-to-disk backup or some file services in the background, which are clearly less important. So what I'm going to do is, let's take the example where I have 50 IOs in the system, and in comes that critical log write. I jump him to the head of the line. He's the VIP, so I execute him first. I don't wait for the other guys to complete. This way, even when the system is busy sharing its resource with many applications, we call that multi-tenancy, by the way, The important guys get to go to the head of the queue, so their performance does not degrade.
So Chris, that definitely helps us address this issue of segmenting workloads, for
Correct.
example. But what about the back-end performance of the system?
What we've done with the Axiom is we've actually built a 16-port fiber channel switch into the back of the, if you look a little bit behind me, you will see the two larger control units back there, what we call a slammer, and that does all the I/O, host facing and back end. The back end of each of those is a 16-port fully switched fiber channel mesh. So no, it does not slow down, even though the system is very busy.
And I'm assuming that each one of those controllers has dedicated RAID controllers inside?
We have broken that mold also, recognizing that the RAID controller has to perform this very complex but critical function called an exclusive OR to generate parity for data protection. Now, if it's too busy or it can't get to the disk to do that, guess what? Your performance slows down. So we have decoupled the RAID controllers from the actual I/O controller, what we call a slammer, and we've embedded the RAID controllers actually in every storage enclosure, what we call a brick, in the system. So when you buy more capacity, you get 2 more RAID controllers. Largest system, you could have 128 RAID controllers, 64 enclosures. They're always in pairs for redundancy, which means they all operate in parallel. I mean, it's pretty easy to imagine the performance difference of 128 people working on a problem versus just 2. No matter how fast and smart those just 2 are, it's still just 2.
So what does this all mean for the business in terms of running the day-to-day operations? What do I tell a CFO or a CIO? How does it help them?
The big benefit is it's high utilization. Again, everyone claims to have high utilization, but when you look under the covers, it's usually a bunch of smoke and mirrors and arm waving. We deliver high utilization by every time you add a brick, remember 2 more RAID controllers for more IOPS, so you can actually use everything you buy. The Gartner Group had an interesting study, and I believe IDC did also, that said the average user gets 40% utilization of a storage system. Now, if you're a CFO, this is kind of amazing. You say, I built you a big factory and you're running it at 40% utilization. You know, why not 80? Why not 100% utilization? Answer is because the system slows down to an unacceptable performance. So I can't use everything I bought. At Pillar, we try to deliver on the high side of 80% utilization, again, through our distributed RAID and ability to scale slammers, so I can add more cache, more back-end bandwidth, more host-facing bandwidth, and allow you to use everything you can buy. So at the end of the day, this is a statement about money. It's getting what you pay for, using what you pay for, and not having excess unusable capacity on the floor.
But does the Pillar Axiom offer other features that are standard with storage systems in the industry?
Yeah, for instance, when we ship the system, there is no base license fee. We just include that. You also get thin provisioning, all included and thrown in. Thin provisioning allows you to create a virtual LUN that appears to be much larger than it is, and I only allocate physical space when you need it. Again, we're trying to drive the utilization number up so you can use everything you pay for. We have a complete set of copy services, so I can do volume replication, I can do writable snapshots, we call those clones. You can have thousands of clones, more than you'll ever need, so you don't run out. We have a concept called storage domains that allows me to take a very large Axiom system and literally subset it into smaller virtual systems so that I can isolate applications from each other, which in certain applications and compliance reasons I'm required to do. And we have a full suite of replication software driven by a unique architecture that offloads the heavy lifting of the replication from the system so it does not slow down when I turn on replication. And we support kind of anything you want to do with it. Could be simple point-to-point, multi-point, bi-directional replication, fan in, fan out, multi-hop. You draw me a configuration, I can probably handle that.
Well, Chris, thanks very much for joining us today to help us address this issue of adding capacity and balancing performance at the same time. It's been very interesting.
I appreciate that very much, Aaron, and I appreciate the opportunity to be here.
Well, thanks to Chris, we now know how to get even more utilization out of our storage without losing performance. And Chris should know he's been doing this for more than 30 years. If you need to learn more, go to oracle.com/storage. Well, that's all I have for now. Join me next time on Fact Finders.